Hello friends, the topic for today is 8051 input output ports or IO ports. A port is a pin where data can be transferred between 8051 and an external device. 8051 has four 8-bit ports P0, P1, P2 and P3. Apart from being used for input and output functions, some of these pins have other functions assigned to them as well. In today's video, we'll learn the input and output ports of 8051. Let us start. Welcome to our channel Engineering and Technology for You. If you are not subscribed to our channel, kindly subscribe and press the bell icon so that you can get notifications for future videos. The topic for today is 8051 input output ports. Introduction. A port is a pin where data can be transferred between 8051 and external device. 8051 has four 8-bit ports P0, P1, P2 and P3. Each port has a D-type output latch for each pin. The special function register for each port is made up of these 8 latches, which can be addressed at the SFR address of the port. So the SFR are special function registers where the port address is available for the user and the port are directly addressable using that address. The port latches are different from port pins. The data on the latches need not be the same as that on the pins. So when we are working with the ports, we have to be careful. Then let us come to the port 0. Port 0 address is 80H. This is an 8-bit addressable input output port. It has a dual role. Apart from being used as an IO port, it is used as a bidirectional lower address and data bus for the external memory, that is 80 to 87. Now the port address are shown here in table 1. So the hex byte address is 80H and the individual pin address, that is P0.0, it is 80, 0.1 81, 0.2 82, 0.3 83, 0.4 84, 0.5 85 and 0.6 86 and 0.7 87. So these are the addresses of the port pins in the SFR. So if you give this address, you can directly access the port pins. Then the structure of port 0. Here you can see it has got a latch, which is for every pin there is one latch, and to this latch the input is given to pin D input and Q and Q bar are the outputs. Then this is a buffer for reading, and here we have the address data line, and this is the control line, and this is the control which will control the flow of data. And here we have two MOSFET transistors, and this is connected to the VCC, and port pin it is here, connected here. So when control is 1, now this block, when it is 1, the port is used for address or data interfacing. So here you can see this will be used line, and when control is 0, the port can be used as a bidirectional IO port. So in this way the port will be used. Then let us see how port 0 can be used as an input port. Now here again we have drawn the same diagram with the port 0 pins. So let us assume that control is 0. This control is 0. Now when port is used as an input port, 1 is written to the latch. So here we'll write 1 to the latch. In this situation, both these transistors, they will be off. You can see here both the MOSFET transistors, they are off. MOSFETs are off. So hence the output pin, say it will float. This will float. Hence whatever data written on the pin is directly read by the read pin. So this is the read pin. It will read the data. So in this way, the port 0 will act as an input port. Then let us go to the next part, port 0 as output port. So suppose we want to write 1 on pin of port 0. So 1 is written to the latch which turns off the lower MOSFET. Due to 0 control signal, upper FET also turns off, as we have seen in the last figure. Here we want logic 1 on pin, but we are getting floating value. So to convert that floating value into logic 1, we need to connect resistor parallel to the upper FET. This is the reason why we need to connect pull-up resistors to port 0 when we want to initialize port 0 as an output port. So when we connect the pull-up resistors, so here the pull-up resistors, they have value of 10K each, and they are connected to the port pins and VCC. In between this, they are connected. So when we connect them, port 0, we can use it as an output port. So we can out 0 as well as 1 on the port then. Then dual role of port 0. So when connecting 8051 to an external memory, port 0 provides both address and data, that is 80 to 87 lines. So when AL is 0, it provides the data D0 to D7, and when AL is 1, it provides the address A0 to A7. Then AL is used for demultiplexing address and data with the help of this latch 74LS373. This is a 8-bit latch. So here we have shown the diagram for that. This is 8051, and this is the external memory which is connected to 8051. So this is port 0. So that will have this is connected to the latch, and at the output of the latch we will get the address A0 to A7, and here this will be the data lines D0 to D7, and the ALE signal will be used for latching the address in the latch. Then other port 2 is used for the external say higher order address bus, so that is also shown here. So in this way we can have the dual role of port 0. Then let us see the port 1. So port 1, the address is 90H. So again it is a 8-bit quasi bidirectional bit addressable port, and the addresses are given here in this table. So the byte address is 90H, and the bit addresses, so this P 1.0 it is 90, 1.1 91, 1.2 92, 1.3 93, 1.4 94, 1.5 95, and so on. And here port 1 pin can be used as input or output. So port does not need any pull-up register as they are available internally. So in port 0 there was no pull-up that was to be put externally. Here they are available internally. Then upon reset, port 1 is configured as output port. So if you want to configure it as input port, we must write 1 must be written to all bits required to act as inputs. Then there is no alternate functions for this port. It is only used for input and output. Then this is the structure of port 1. So here the other things are same as port 0. So this is the latch. So the inputs and the outputs of the latch are here, and these are the buffers. And here only this is a internal pull-up which is provided in port 1. It is not there in port 0. And these are the pins of the port. Then let us see how we can program port 1 as output port. So here we have written a code which will continuously send out to port 1 alternating values of 55 and AAH. So first we load the accumulator with 55H, then copy this A to port 1, then we call a delay, A called delay, then we complement A. So when we complement 55, it will be AA, and then we give a jump SJMP back. So jump will be again the A is loaded into the port A, port 1. In this way, this will give continuously alternate values 55 and AH on port 1. Then let us see how we can use port 1 as input port. So in this program or code, we are configured first as an input port by writing 1, and then the data is received from that port and saved in the registers R7, R6 and R5. So first we move A with the value FF, that is all ones. So all the lines of the port we are configuring as inputs. Then move P1 comma A, so that will copy A to the port 1. So the port 1 all lines we are putting 1 1 1 1 1. Then we are copying the port 1 to A and then moving A to R7 register. So it will be saved in R7 register. Then we give delay. Then again we take port 1 and copy it to A, and then A is copied to R6. So it will be saved in the R6. And again we give delay, A called delay, and then port 1 is copied to accumulator, and from accumulator it is saved in R5. So in this way we can, the data received from the port 1 is saved in R7, R6 and R5 registers. Then let us go to the next, port 2. Here this port is also 8-bit passive bidirectional bit addressable port similar to port 1. So the addresses are shown here. The byte address is A0 and the bit addresses are given here. So A0 to A7, these are the bit addresses for the respective pins. Then it can be used as a input or output, and again it does not need any pull-up registers as they are available internally. Then upon reset it is configured as an output port, and when we want to configure it as input port, one must be returned to all its bits required to act as inputs. Then it has an alternate function. It provides higher order address bits, that is A8 to A15, when connected to external memory. Then let us see the structure of port 2. So the structure, this part is similar to port 1 or port 0. Here the internal pull-up is similar to port 1. So almost the structure is same, only the here the input is the address, that is A8 to A15. That will be the only difference. Then port 2 as output port. So here in this code it will continuously send out alternate values of 5, 5 and AA. Similar example we have taken. So first we load 5, 5 into port A, and then A2 port 2, then call delay, then CPLA SJMP back. Then port 2 as the input port. So here we are configuring as the input, and then the data is received from that port and sent to port 1. So here for this configuration we are sending this 0FF in port A, and then that is first we load it in the accumulator, and the accumulator is copied to port 2. So port 2 all the lines will be input. Then here we move A comma P2. So port 2 is moved to A, and then A is copied to P1. So it will, the port is sent to P1, and then there is a SJMP, that is back. We will jump back here. So again this will be repeated continuously. So whatever data is received from port 2, it is sent to port 1 with the help of this code. Then let us go to the dual role of port 2. So here when we are connecting 8051 to external memory, port 2 provides the higher order address bus A8 to A50. Then along with P0 it will provide the 16-bit. So P0 will provide the, say this is the latch, the lower order address bus is latched with P0, and the higher order address is provided by the P2. So this total will be the 16-bit address whenever we are connecting the external memory. And this is the latch for latching the address, and here we are giving the signal ALE for latching the port 0 lines AD0 to AD7. Then port 3, the last port. This port is an again 8-bit bidirectional bit addressable port, and the addresses are shown in this table. So the address, hex address is B0, and individual address will be say B0 to B7. Those will be the address for individual pins. Then it can be used as input or output, and it does not need the pull-up register similar to port 1 and 2. Then it has got alternate functions. We'll see the alternate functions. And this is the structure of port 3. So here alternate input functions, so they are there, so that's why this is for that. And here also we are giving the alternate output functions, input functions and output functions. These inputs are there, and this is the internal pull-up register. The other structure is same as port 1 and 2. So this is the alternate functions of port 3. So here we are having 3.0 and 3.1. They are used for the serial communication, receiver and transmitter data for the serial communication. Then port P3.2 and P3.3, they are for the external interrupts INT0 and INT1. So they are pin number 12 and 13. Then P3.4 and P3.5, they are the T0 and T1, timer 0 and timer 1 inputs. Then pin 3.6 and 3.7, they are for the write and read signals. So they are pin number 16 and 17. So these are the alternate functions of port 3 apart from being used as a input and output port. With this we come to the end of this video. If you have any questions, you can find me at Facebook, Twitter, Gmail or Instagram. Then if you like the video, press the like button, share with your friends and subscribe to our channel Engineering and Technology for You, and hit the bell icon if you want to get notifications about future videos. Then thanks for watching. Have a nice day.